more than one independent sources, the response in a particular element we can find out as a response of individual independent sources are working. It means the output or the response in any element of the circuit will nothing but the algebraic summation of the individual response due to independent sources in that particular branch or element. Is it okay? In the Thevenin theorem, we have seen the entire complicated circuit two-port linear network we reduced in single form. In that single form, we had only one voltage source in series with resistance. Okay. So across the load terminal, in the question they'll mention the load terminal A and B, or they'll mention 2 points across which they'll connect one load resistance, and they'll say that find out the voltage or current into this load element. So we can deduce the circuit across A and B in a very simple manner, and the deduced circuit will contain one voltage source, one resistance, and that voltage source is nothing but the Thevenin equivalent voltage, and that resistance is nothing but the R equivalent. Or in other words, I can say the Thevenin equivalent voltage is nothing but the open circuit voltage across the points, across the terminals. Means Thevenin equivalent voltage is nothing but you have to calculate the voltage while opening the terminal. If any load is connected across the terminal, please open that and find out the open circuit voltage, and that open circuit voltage is nothing but your Thevenin equivalent voltage. Okay, the Thevenin equivalent voltage is over. Then come to the resistance, R equivalent. R equivalent is nothing but the resultant resistance seen by the terminal is nothing but the RTH. And how to calculate RTH? See, while calculating the RTH, there are two types of cases. In first case, we are having only independent sources in the circuit. In the second case, we may have dependent source also. Yes, independent source plus dependent source in the second case. We may have like this circuits. So in the simple circuit that contain only resistances, how we find out the resistance, you know very well. We'll combine them series and parallel. We'll check the series combination, parallel combination, and according that we'll apply the formula. For the series, the resistance will be added. For the parallel, the formula is available with us. But in the circuit where we are having independent sources, also to calculate the R equivalent, we first turn off the independent sources. Two types of independent sources we have, current source and voltage source. How to turn off the voltage source? By short circuiting it. If you want to turn off the voltage source, just short circuit it. If you want to turn off the current source, we have to open it. Is it okay? So while calculating the R equivalent in the circuit, if you are having voltage source, short it. If you are having current source, open it, then proceed. Then calculate the equivalent resistance across the terminal. In the second case, suppose you are having dependent source also with independent source. So in the circuit, independent source will turn off, but we can't turn off the dependent sources. Why? Because the value of dependent sources depends on the value of circuit parameters. So we can't turn off the dependent source. Even we can't touch the dependent source in the circuit. So what we have to do then? We'll apply one imaginary battery or voltage source across the terminal, and we'll assume that current in the circuit because of this battery is I. Now by some method we'll calculate V by I, and tell me what is the V by I? V by I is nothing but the resistance appeared across the terminal. Is it? The current sucked by this network is nothing but the V by R equivalent. So this is the procedure to find the R equivalent. I hope it's clear to you. Today I'll take another problem based on Thevenin theorem. So if you people have doubt, it will be clear out. So again I'm telling you friends, if you want to become conceptually strong, do as many as problem as you can, and if you will solve the problems, you will get doubts. Okay, if you will get doubts, you will ask the doubts to your friends, your doubts will be clear out, and day by day you will become conceptually strong. So here we go. Today we'll start the session. In the last time we have done this problem, right? And we have done this. These are the two examples I have covered on the Thevenin theorem. Now friends, again I'm getting another question, and he is saying, find the Thevenin equivalent circuit of the circuit in the figure left to the terminal. Here the terminal is given, and what he is saying there, find out the Thevenin equivalent voltage. What is the Thevenin equivalent voltage? Thevenin equivalent circuit, the Thevenin equivalent circuit is nothing but this entire two-port linear circuit. You have to convert in single source and single resistance across the element, across the terminal A and B. See, A and B is same. This entire circuit I have to reduce in this form. Is it okay? So again, this is up to you. This is homework for you. You have to do it. Okay friends. Now I'll show you this, how to do this. Obtain the Thevenin equivalent circuit of the given figure. Again for this circuit also, what we have to do? Single source, single resistance. Is it okay? Single source, single resistance, we have to convert. This is the terminal. So I'm doing this circuit for you. Come over the circuit, and the circuit is given here 5 ohm, across which we are having Vx and dependent source plus minus 4Vx, and here we are having 15 ohm. This is the terminal given, A and B. Is it okay friends? Now what they are asking, they are saying find out the Thevenin equivalent voltage, and Thevenin equivalent voltage is nothing but one source, one resistance across terminal A and B. I can say the given terminal. This is RTH, this is VTH. So I'll start the calculation for VTH. So to start the calculation for VTH, I have to make sure that the terminal should be open. Yes, here the terminal is open. The terminal is open. Is it okay? Now I'll start my calculation. So before that I'll see what are the parameters given in the circuit. The Vx is given across 5 ohm. It means the current is given in this. What is the current? Voltage divided by resistance. Vx by 5 is the current in the circuit, and direction of the circuit current is this, right? Because here is the potential high, here the lower potential. So I can say the current in the circuit is Vx by 4. Is it okay? So can I apply KVL in this circuit only? In this circuit only. I know I have to calculate this VOC. VOC is nothing but the voltage across this 15 ohm. Right? Are you getting this? Good. Now come to the KVL now in this equation. Okay, the current is coming from this direction. So drop across the resistance will be like this. Here will be like this. Is it okay? Why? Because this is the direction of current. And current flows from higher potential to lower potential. Okay, I'll start from A. I'm getting 10 into Vx by 4 with positive sign. So 10 into Vx by 4, okay, fine. Minus 4Vx, minus 4Vx, fine. Come to the 15 now, ending is the positive 15, and the value is, current value is Vx by 5, okay. And come to this, directly we are getting Vx. and this is the end. So all are Vx. Vx is common. Inside something equal to k equal to 0. So what is the value of Vx? Vx is 0. Vx is 0. So Vx by 5 will be 0. So in this circuit, the current is zero. If current is 0, so can I check this voltage drop across 15 volt? So yes, I'll calculate this. Current in this 0. So voltage across this will be absolutely 0. So your VOC is nothing but 0 volt. This is nothing but your VTH. Why 0? Because current flowing in the circuit is 0. And by the common sense also we can say there is no independent source in the circuit. How current will flow in the circuit? So if there is no current, no voltage drop across any element in the circuit. So your VTH is simply 0 volt you get. Is it okay? Now calculation is remain for RTH. Come here then. We'll do calculation for RTH now. So it contains dependent source. This is dependent source. I told you the procedure across the element. We'll apply unknown energy source V, and due to this energy source, suppose I'm getting current I. And if you are able to find the V by I ratio, this will be nothing but R in. Is it okay? It will be nothing but R in. So here, tell me the voltage across here. This is V. Is it okay? If this is V, so can I apply here what? Nodal analysis? Yes. Now we are doing the calculation for RTH. I can apply the nodal analysis here. So by the applying of nodal analysis, I'll get V minus plus 4Vx. Come here, no battery is given. This is only voltage is given. Here it is 0. Divide by 10 plus 5 equal to 15. Come to the next is V by 15. Come here in the third branch, minus I equal to 0. Is it okay? Take 15 LCM. So you will be having V plus 4Vx plus V equal to 15I. So it is 2V plus 4Vx equal to 15I. Equation 1. Is it okay? This is equation 1. Now see, if you will observe carefully this equation, you are getting V and I. Finally, at the output, you need V by I. Is it okay? So you have to remove Vx from here. So this is the Vx. What is the value of Vx now? How will get the Vx in the form of V? Yeah, easily we can get. How? See, come here. The current is coming I. The voltage, this voltage is entirely here. This is the voltage over here. In this branch, the current is Vx by 5. Is it clear to you people? Please observe this carefully. So, can I say this? I think this is already done by this. This is same relation we'll get. Then, what is the Vx by 4? The direction of Vx by 4 is this. This is the current. Vx by 5. Sorry, Vx by 5 is the current. And this current is nothing but this V, higher potential, minus plus 4Vx, and voltage across here with respect to ground is given is Vx. So this is Vx divided by 10 only. The current is flowing in the circuit. This current I am calculating. Here the voltage is V. Here is the plus 4Vx. Here is the Vx. This Vx is given with respect to ground. Everything is okay. Divide by 10. So this is the current. This is the current over here. Vx by 5. 2 times. So it will go 2Vx equal to V plus 3Vx. Right. So minus Vx equal to V. We got this relation. Now we'll put this value of Vx over here. It is 2V plus 4 and Vx is nothing but minus V equal to 15I. Is it clear to you? Now 2V minus 4V, it will be minus 2V. It is equal to 15I. Now V by I, come to V by I. V by I is nothing but 7.5, negative. Negative shows that we are having dependent sources inside the circuit. So sometimes in the dependent source problem, the value of resistance will be negative. Is it okay to you people? Sometimes it is negative, and I think we are not making any mistakes over the calculations. Maybe. It's depend on you. Please check it. So your answer is, your resultant network is, in your resultant network we have to show the Thevenin equivalent voltage with, in series with resistance. The resistance is 7.5. This is the terminal given A and B. Here the voltage is 0 volt, like this. Means this circuit is dead circuit. Why dead circuit? Because there is no independent source. No independent source, no energy in the circuit. That's why the circuit is dead circuit. I hope this question is clear to you, and I think you are getting the concepts of Thevenin theorem. Okay friends, come to the next now. Come to the Norton's theorem now, right? Norton theorem says, the Norton theorem is also similar to the Thevenin theorem. But in the Norton theorem and the Thevenin theorem, the difference is, in the Thevenin theorem, at the output stage, the output circuit, single circuit contained voltage source. Is it okay? In resistance with equivalent resistance of the circuit. In the Norton theorem, the output stage contain current source instead of voltage source, and with the current source we know already the resistance is connected in parallel. This is the load terminal and this is R equivalent. This is the Norton theorem. So they are they are connected with each other, I can say, or this is here what I am doing, source transformation. This is the source transformation or not. So see, in the Norton's theorem, the linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source IN, the current source IN, in parallel with resistor RN, where IN is the short circuit current. See, Thevenin equivalent of this is VTH and RTH. I'm going to compare, so the concept will be clear for you people. See, both Norton theorem and Thevenin theorem, both are same, but difference is, one is the source transform of the other, right? See, in the Thevenin theorem, the linear two-terminal circuit can be replaced by single voltage source in series with resistance RTH. In the Norton theorem, the same circuit, linear two-terminal circuit, can be replaced by one single current source in parallel with resistance Rn. Here in the Thevenin theorem, the VTH is open circuit voltage, right? Open circuit voltage. Open circuit voltage. But here the current will be the short circuit current. Short circuit current through the terminal. These are the terminal. So see, IN is nothing but the short circuit current. Okay. And RN is the input R equivalent. RN, RTH both are same. Okay. Is it okay to you people? So in the Norton theorem, the IN is nothing but short circuit current. Okay. In the Thevenin theorem, the VTH is nothing but open circuit voltage. So to calculate the voltage across terminal, we have to open the terminal. To calculate the maximum current across the terminal or in the terminal, we have to short the terminal points. Is it okay to you people? And Rn and Rth both are same in both cases because resistance value is not going to change. Is it okay? This is nothing but the Norton's theorem. And he's saying that Rn is the input or equivalent resistance at the terminal when the independent sources are turned off. It's basic procedure to find out the RTH across the terminal. We have to turn off all independent sources available in the circuit. Please remember not dependent sources. Okay. Come to the next. Find out the Rn and Rth. Thevenin and Norton resistance are equal. So we know the procedure of RTH. But what is the IN? See, if this is the circuit given to you, this is the entire circuit in which having so many elements connected with each other like this. This is the terminal A, this is the terminal B. It's two terminal device or the two terminal element. While calculating the Thevenin equivalent voltage, we have to open VAB, means in this case only we have to find VOC. This is nothing but VTH. But if we want to find out the IN, we have to short it. We'll short it and then in the short circuit only we'll find out the IN or ISC. I can say the short circuit current is nothing but IN. Tell me one thing, why we are shorting this here and why we are opening there? See, if you want to get current over here, you can't open the circuit. See, this is A, this is B. If you want to get IN, can you keep it open? If you will keep it open, there is no current. IN will be 0. So that's why to find out the value of IN, we have to close it. We have to short it. Okay, in this case, the current will be ISC will be equal to IN. While in the Thevenin theorem, across A and B, you want to calculate the VTH. So will you do like this short circuit? If you will short circuit, the voltage becomes 0. No difference. There is no difference between 2 points. Is it okay or not? So to get the maximum value of VTH, we have to open it. This circuit, we have to open it. Is it okay to you people? I hope this Norton's theorem is also clear to you. Okay. Now remember, here also the point is the dependent and dependent sources are treated as the same way as the Thevenin theorem. Everything will be same. You already know the procedure to calculate RTH. The procedure is same to calculate for Rn also. You know the procedure how to calculate VTH in Thevenin theorem. Here also you know the procedure to calculate IN in Norton's theorem. We'll take one example here. But before that, we should understand the Thevenin versus Norton's theorem. What is the relation between Thevenin and Norton's theorem? Actually, they are dual to each other. You know, see, Rn equal to RTH and IN is nothing but VTH RTH. Suppose you don't want to calculate the Norton form. So simply do one thing. Just find out the Thevenin equivalent circuit across terminal A and B. This is nothing but VTH and just transform it. You will transform it in the form of current having parallel resistance, the terminal A and B as it is. This is nothing but RTH. What about this IN? This IN is nothing but VTH by RTH. This is nothing but source transformation or not. So can I say this is essentially source transformation? For this reason, source transformation is often called the Thevenin-Norton transformation. Please remember this point. Source transformation, I can say Thevenin-Norton transformation also. Okay. I hope this is clear to you. We'll take example on the Norton's theorem. Please read it. Find the Norton equivalent circuit of the given circuit in both figure A and B. So first we'll take this circuit. our task is to find out the Norton equivalent circuit. Means this entire circuit you are going to replace by, wait a minute, you are going to replace this circuit by this. Terminals are same, A and B, but this circuit now replaced by this. Is it okay to you? Now see, we'll find, this is Rn, okay, we'll find Rn and Rth. So I'll take this problem on a fresh page. The given problem is two ampere current connected with 4 ohm. Here this is 12 volt, connected further 8 ohm, and this is 5 ohm. These are the terminal A and B. Is it okay to you people? Now see, the task is, our task is, we'll convert this entire circuit in the form of single current, single resistance. I hope you're getting this, right? The terminal is same. So first calculate the RTH. Here we are calculating RTH. For the RTH, you know the procedure very well, I think. Wait a minute. For the RTH, we have to turn off the all independent sources from the circuit. Turn off the sources. I'll turn off the source. This current source will be open. This 4 will be as it is. This 12 will be short circuit. This is 8. This is 5. Like this. You have to calculate Rn over here. So this is the open branch. 8 and 4, they are connected in series. Okay. So 8 and 4, 12. 12 plus 5, they are connected in parallel. So this is nothing but 12 into 5 divided by 17. This is nothing but Rn. Okay, Rn calculation is over. Our Rn is 12 into 5 divided by 7. Is it okay to you? Now come to the Rn. Come to the Rn now. Sorry, Rn is done. Come to the In. How to calculate In? Okay. I'll erase it first. Everything. The Rn calculation is over. Now we'll come to the In calculation. Okay. For the In calculation, the condition is we have to short the terminal. The terminal will be short like this. Is it okay? And then now we have to calculate the current over here. Remember one thing. If you are having two terminal A and B like this, in between these two terminal 5 ohm is connected, and suppose you are short circuited these 2 points by another branch, it means now you can remove this 5. Why? Because there is a zero importance now of this circuit, because once you short circuited it, there is a no current in this. This will become dead. If in this circuit, see, in practical example I'll tell you. Take a bulb, okay, and connect this bulb to a battery. Okay. Like this. What will happen if you will apply battery, 5-volt battery? It will glow light. But if you manage to sort it, means in the path of this, you connect one simple wire like this between 2 points, terminal points. So, if you do this bulb will be off. There is no light in this. You can check it practically. Why? Because now current will go into this way and will come like this again. Because current always follows the path in which having minimum resistance. In the minimum resistance, current will be high, and the resistive element, the current will be low. Simple. Come to the second question now. Okay. This question is saying again, across the terminal A and B, we have to find the Norton equivalent. Okay, it means for this entire circuit, you have to replace it by single current source and single resistance across the same terminal A and B. Is it okay? I am taking this circuit on the fresh page. Okay, the given circuit is four ohm, 10-volt battery, 5 ohm, here I have 2ix. This is the terminal A and B. Okay. Now, we have to find the Norton equivalent of this circuit, right? So again we need two things. Number one is IN, and the second is RN. Okay. So first we will start with the IN. IN is nothing but the first the calculation for IN. IN is nothing but the short circuit current. Short circuit, you have to short circuit to the terminal, this terminal A and B. You have to short it like this. You shorted it, okay. Now once you sorted it, this is the ground, this is node A, this is another node. Tell me, what is the voltage across this point? Is this 10? Directly 10 volt given? Because 10 volt is given with respect to ground. So anything with respect to ground at a particular point, we can assume that particular value is here only. See, here is the 10 volt. Now, I'll apply the KCL here. Node analysis. This 10, this one. Okay. You can do one thing. Don't apply here. Apply here directly. Because you need this current actually. ISC. Right? Assume your current is ISC like this. So here I am going to apply. Tell me here what is the voltage here? 0, because this branch is directly connected to the ground. Okay. So this is the 0. 0 minus opposite branch resistance. Tell me. Opposite branch. The opposite point the voltage is 10 divided by 5. Okay. Fine. Next. This is the upcoming current. Minus 2ix. Okay. Fine. This is the outgoing current. ISC. Okay, fine, equal to 0. So it means minus 2 minus 2ix plus ISC equal to 0. So finally you are having 2 plus 2ix. This is your equation 1. Now the question is, what is the value of ix? See, this is the ix. What is the voltage across 4 ohm resistance? This is 10. Why? Because this is the 10 given over here. See, this is the 10 given over here now. 10 is in the voltage in between point this and this. This is the 10 volt across 4. So the ix is nothing but voltage divided by resistance. It means 2.5 ampere. So 2.5 ampere you will put here. So 2 plus 2 into 2.5. So this is 7 ampere. So your ISC is nothing but 7 ampere. So you will replace this via 7 ampere. Is that okay? Now come to the calculation for Rn. And Rn is nothing but same as RTH. And I think you remember the procedure for RTH. Is it okay? We have to open the circuit and then find out the RTH. Okay? Okay. Let's see here. I have to open this. Yes, I opened it. I will remove this thing. Yes. Okay, fine. Now, I have to see. I am having dependent source over here. So while calculating the RTH of this circuit, Rn, okay, this circuit, I have to turn off the independent sources and nothing I can do with the dependent sources. I am having one independent source and I can short this. I can short this. Short means now voltage is 0 because this point is directly connected to the ground. And I told you once, if any resistance connected in parallel with a short circuit, it means this resistance is dead now. This is the dead circuit. Because the voltage difference between 2 points is same, 0, 0. So no current will go inside this. This will become dead circuit or dead resistance, right? So this 4 is not in the circuit now anymore. So I can erase it. Yes. Yes, I can erase it. So there is a no current in that. It means Ix is 0, right? Because in that 4 the current is, tell me, the current is Ix. And we got the value of Ix. Ix is 0. Okay. As we short this voltage source, the Ix becomes 0. So what will be the value of this circuit? 0. Current is 0 means this is open circuit. Current is 0 means this is open circuit. No current in the circuit. This is open circuit. Because we got the value of Ix, no? It's 0. So here, now circuit will be open, the current will be 0 here, right? So, the RTH is now simply you are looking to 5 ohm only. Is there any other else here given? No, directly Rn is nothing but 5 ohms. This is your simple circuit and this is your simple answer. Now, I am taking one problem from GATE, and that problem is, let me draw it. Okay. The given problem is, a minute. This is 9K and this is 1K. Here we have 99 IP. Okay, fine. This 99 IV is connected over here, and in between point 1 and 2 I'm having 100 ohm. Here the point is given, or I can say the terminal is 1 and 2. Okay, and they are saying, the impedance looking into nodes 1 and 2 in the given circuit. Here they are saying the impedance looking in 1 and 2, and our options are given here: A 50 ohm, B 100 ohm, C 5K, and D 10.1K. This is the simple circuit we have. Okay. Now they are asking, find out the impedance looking to the terminal 1 and 2. So I can say R12 I have to find out. See, you know already the procedure how to find out the R resultant resistance, right? If we are having independent sources in the circuit, we have to turn off. If we are having independent sources of energy, we have to turn off them. Right here, I don't have any independent sources. So in this circuit, you can see the dependent source is given, right? Dependent source is given. So you know, when the dependent source is given, how to calculate RTH? Across this point, I will apply battery V and assume the current from the battery is I. So voltage across this point is nothing but V, because directly battery connected over here. Now I will apply the KCL over here. Okay, so I will get V by 100. From this side, IV is coming. Okay, fine, incoming current. From this side, 99 IB is coming. And here, I is coming. So, minus I, I'll take that side. So, V by I. So, you are having V by 100 minus 100 IB equal to I. Now, if you are able to replace this IB in terms of V or I can get the value of V by I from this equation. So, please observe here carefully. This IB is nothing but, here the potential is 0, here the potential is V divided by 9K, 1K, 10K. Is this IB? Tell me, right? So, I can replace it. V by 100 minus 100 as it is. This IB will be minus V by 10K equal to I. Is it okay? This minus and this minus will become plus. This is V by 100 plus. This will become V by 100 equal to I. So, this will be 2V by I equal to 100. So, V by I is nothing but your R, and that is 50 ohm. I hope this one is also clear. So, this is the answer. Okay, this is gate problem. Is it okay to you? Fine. Come to this question now. Find the Norton equivalent circuit of the given figure at the terminal A and B. Okay, fine. Again, I have to replace this circuit by one current source, that is IN, and one resistance. The terminals A and B are same. Okay, I'll take this problem on a fresh page. The given circuit is (6 ohm, 10 ampere). Here the dependent source given. The value of this source is 2Vx. This is voltage source, okay. And here 2 ohm is given resistance, Across this resistance we are having Vx and the terminal points are A and B. Correct? Now come to the solution part. We have to replace this entire circuit by single current IN and single resistance Rn. The terminal A and B will be same. Okay, A and B. Fine. Now we have to find out the IN. What is the procedure to find out the IN? IN is the short circuit current. If IN is the short circuit current, means we have to short the terminal like this. If you short the terminals, this voltage Vx becomes 0 or not? This Vx becomes 0. Why? Because you short this. And across this A and B, initially Vx is given, right? Because this is the starting terminal, this is the ending terminal of Vx. And these points are nothing but A and B. Now A and B are sorted. Sorted means here the voltage is 0. Is there any voltage difference between 2 points if they are short? No voltage difference. Vx becomes 0. Once Vx becomes 0, this automatically will become 0. Though this is the voltage source. Voltage source becoming 0 means we have to short this. We have to short this, not open. Okay, if you want to take voltage source turn off, we have to short it, right? This is also 0. Why this 0? Because Vx 0. Why Vx 0? Because to find out the value of current, we shorted terminal A and B, and because of that Vx becomes 0. So the dependent source which was dependent on the Vx will also become 0. Now your circuit is like this, and your task is to find out ISC. Is it okay? And I told you, if the short circuit wire comes across any resistance, that resistance will become dead resistance. So you can remove this resistance. Okay, you can remove this resistance. Nothing is here now. We are having only short circuit current. Now see this circuit, the beauty of this circuit. Here the 10 ampere current is coming at this point. Here I am having two paths. One is 6 ohm resistance, one is short path. And I told you earlier, the current will always follow the short path. So entire 10 ampere current will come over this. So ISC is nothing but 10 ampere. Is it okay to you people? So your IN is nothing but 10 ampere. Now you have to calculate the Rn. Okay, so again I'll read out the circuit. The given circuit is 6, 10 ampere, dependent source, 2 Vx, here 2, we'll use Vx over here. Here we go with terminal A and B. Procedure to find out the R equivalent is nothing but turn off the independent sources, if any. Yes, I have one independent source. Here I am having current source. How to turn off the current source? By open it from the circuit. Is it okay? There is no current now. I hope it's clear now. Sorry, this is directly connected. Fine. Okay, now your task is to find out Rin. Though dependent source involved in the circuit, according to my procedure, I have to replace it by a battery V, and the current due to that battery is I. Okay, now over here I'll apply the KVL. What is the voltage across here? Either you can take this V or Vx, both are same now in this case. Once we are taking this battery directly connected to this point, it means this is V and V is nothing but Vx over here. You can see this, because the Vx is also given voltage across these points, between these points, and we assume directly V also. So V equal to Vx. Now apply the KCL over here. So this V minus plus 2Vx, no other battery I am having, directly 0, divide by 6. What about this? Yes, V by 2, and in this branch I is coming equal to 0. Now I know V is equal to Vx. I'll replace this Vx by V. So we are having V plus 2V divided by 6 plus V by 2 equal to I. Is it okay? Take LCM 6. Here 3V plus 3V equal to 6. Oh sorry, equal to I. So finally you are having 6V equal to 6I. So V by I is nothing but 1 ohm. So your equivalent circuit is terminal point is A and B. This is 1 ohm. This is 10 ampere. Okay, this is your answer. I hope this one is also clear to you. Come to the next one now. See, this is the answer. 1 ohm and 10 ampere. I'll take one gate example now. This problem came in 2014. The problem is given 5K. Here we are having 10 volt. Again 5K. And it also involved the dependent source. Terminal C and D, and across this terminal only they have given Vx. Okay, and the question is, find out the Thevenin equivalent resistance in kilo ohm across CD. Find out RTH in kilo ohm across CD. Okay, this is our question. Now see, observe this question carefully. Sorry. The source involved dependent sources, right? While calculating the RTH, the procedure is turn off the independent sources. Do we have independent source in the circuit? Yes, we have. I'll turn off this then. This is turn off. Turn off means short circuited, because this is the voltage source, okay? This voltage source is turned off. Okay, fine. Now in the next step, though we have involved with dependent source, wait a minute. So I'll take battery over here, see, like this. And the value of this battery already given Vx. Vx is nothing but the voltage given across two terminals, and that voltage is given already Vx. Is it okay? And the current due to this, I assume I. Do you have any problem over here? Okay. Now your circuit is like this. Now if you are able to find out V by Vx by I, that is nothing but your RTH. Is it okay? Your task is to find out Vx by I. If you can find this, that is your answer, RTH. Is it okay? Now come over here. This is the Vx, fine. This voltage is also Vx across C, because this is given directly with respect to the ground. Okay, fine. Now what you will apply here, tell me first. We'll assume the voltage across this node is V. Now I'll apply the node analysis at V, this V. So node analysis at V minus 0 divided by 5k. Fine. Upcoming current. Okay. And another equation is V minus Vx divided by 5. Correct? Or you can take this I you can take. Incoming current is minus I over here equal to 0. Okay. So your equation is V by 5k, or here I can take Vx, and this is nothing but 10k equal to I if I am right. Okay. Now give this equation 1. If now we can remove Vx, so we can easily find out the V by I ratio. Or Vx, sorry, we have to remove the V. Where is the V? This? Okay, this V. I have to remove this V. If we can remove this V from this equation, we can get Vx by I ratio by solving this. Okay. So we'll see what is the relation between, yes, this I is nothing but Vx minus V, Vx minus V divided by 5k. Is it okay? I have to replace V. So here 5k into I equal to Vx minus V. This V is nothing but Vx minus 5ki. Is it okay? So here I'll replace this Vx minus 5ki divided by 5k minus Vx by 10k equal to I. Okay. I have to erase it, please. Wait a minute. Okay. Come to the equation. So I can write this Vx divided by 5k. Fine. Here it will be minus I. Okay. Here it is minus 10k equal to I. This I'll go this side. So we'll be having Vx by 5k. Here you are having Vx by 10k. Here you are having 2i. Correct? Now multiply this by 2 and 2. So this will become 2Vx by 10k. And here minus Vx equal to 2i. Is it okay? Now here it is, again I have sort of space now here. So Vx minus Vx. This I am taking this side, and this 10k will go that side. 20k is our answer. Is it okay? So our answer Vx by I is nothing but 20 kilo. I hope this is clear to you people. So friend, this is all over about this class. Today we have seen the Thevenin theorem and Norton theorem. We have solved some problems based on Thevenin theorems and Norton theorems. Okay, I hope your concepts are clear, and in the next class we will meet with a new theorem, and that is maximum power theorem and reciprocity theorem. Do homework whatever I have given to you, and solve as many problems as you can. We'll meet in the next class. Till then, take care and bye.